Alright, good day and welcome to today's Autodesk Inventors class. My name remains Oluwatumbi Blessing Olalekon, the founder of Maekll Tech. Alright, today we'll be considering the problem displayed on the screen using Autodesk Inventor. Alright, so as you can see on the screen, we'll be producing the part file, the assembled view, probably the orthographic and the presentation view. Yeah, alright. So now to solve this, basically we're having 4 components in this problem. So I'm going to denote them for you. Okay, this is my component 1. All right, so this boat is our component 2. All right, so these washers, yeah, these washers, they are our component what? Component 3. Okay, and this shaft is, or roller, is our component what? Our component 4. So we're producing each of those components. All right, now I'm going to start with the cheapest of all, which is what? Component 3. That is our what? Our washer. Okay, and if we look at that washer, okay, it says 2, so we are to have 2 pieces, yeah, of this washer. So I'm actually going to create one, then I'm going to want to duplicate it. So 2 pieces of the washer, and the hole inside the washer is diameter 12, while the thickness is diameter 3. So now what about the diameter on the outside? The diameter on the outside actually flushes with the edge of this cast here. So and at the edge of that cast, the dimension there is diameter what? 25, which is the same thing I'm going to use for the external diameter of my what? Of my washer. So coming to my software, Autodesk Inventor software, I'm going to pick any plane. Okay, so with a circle, I create diameter 25, enter. I create diameter 12, enter. I finish my sketch. So finishing my sketch, I click on extrude. With my extrude at the thickness of what? 3. Let me use symmetric, then what? Okay. So I'm going to denote this as my what? Let me denote it as my washer. WASHER, washer. So I denote it as my what? As my washer. Okay, now Control N for another drawing environment. I have this. So which of the parts should we create again? Let us create part number, okay, let us create this this boat. So this boat, this M12 boat. Okay, so let me create the head first, then we decide the length. Okay, that M12 boat. All right, so coming here, clicking on this, I'm going to come here, pick my polygon like this, M12. So I'm going to pick here to here. I'm going to use 22, enter. Finish sketch. I'm going to use extrude at 10. Okay, I'm going to click on this, start new sketch. With my circle, I draw this tangential to that. Finish sketch, extrude. I'm going to use intersect at 45 degrees. At 45 degrees, then okay. So then I'm going to come to the back here, right here, create a new sketch there with my circle at M12, yeah, diameter 12, enter. Finish sketch. Now what's the length going to be? So if you look at our problem here, okay, the length from this area here, so take note of this, the length from this place to this place, yeah, is something 30, if I'm not mistaken. That is 30. Okay, that is length of 30. But remember that distance between this washer here and this place is what? Is 3. So making 33. Distance from here to here is what? 17. 33 plus 17, that is what? 50. Then plus this 3, that is what? 53. So what about this area that actually pops up? So I'm going to just assume, let me just assume it's a table dimension for this. So 30 plus 3, 33 plus 17, 50 plus 3, 53. Let me add from here to here, let me just add something like a 5. So that's going to be 58. I'm doing it at a mark of 58, right? Yeah, mark of 58. So like that. So let me just assume it that way, mark of 58 for that length over there. So I'm going to do that now. Extrude to 58 and okay, I want it to be pointed. I added 5 to it, 5 12, that will be 6. Let's make it 59 instead of 58. Let's make it 59. Sorry guys, 59. So with 59, okay, so I can pick my chamfer at radius 6. Yeah, I think I should have this radius 6. I should have that perfectly. Okay, now I'm going to thread it. It is not, is it fully threaded? Okay, I think, yeah, fully threaded. So I'm going to thread it in full like this through all. Okay, so I'm threading it in full like that. So let me call this my bolt, B-O-L-T, my bolt. All right, so in that order. So new sketch like that, new working environment. So let's move on to the next component. All right, that is going to be this roller. Let's produce that roller. Okay, so the diameter of this area for this roller is diameter 20. Obviously this end is diameter what? Diameter 12. So diameter 20, diameter 12. Okay, those are the two dimensions I'm going to pick, diameter 20 and diameter 12. Then we move on from there. So with my circle right here, I do diameter 20 and I also do diameter what? Diameter 12. All right, then I finish my sketch. All right, so with my extrude, looking at it this way, okay, the diameter 12 from this bottom down here, so here to here is 3 plus 17. Okay, yeah, the dimension is even there, 20. The distance from here to here is what? Is 20. So it's already there, so no need of disturbing myself. So this area down to that direction is 20. Okay, plus, so I'm going to pick this now to this direction here. So that's going to be what length now? So from here all the way here is what? 72 at 72. Okay, I'm going to do it as what? Plus also. Should I do it as plus also? Okay, that's 72. Okay, let me take it together with this. Yeah, I pick the two circles going to that direction, 72. Okay, so I need to create that inward distance there. So I'm going to pick my origin, pick XZ plane, click on this sketch. Let me just turn it like this and like this. F7, press F7 on your keyboard. It is going to slice this thing into two equal parts like that. Okay, so I'm going to look at my object again. All right, so this area here is at, I think that should be at 60 degrees. It should be at 60 degrees. Yeah, it's usually at 60 degrees. This area here at 60 degrees. Okay, yeah, at 60 degrees. So clicking on our object right here, I'm going to create this line like this from here all the way down here. Okay, somewhere here, like this and like this all the way to the top. All right, so with my dimension, this the angle from here to here is going to be 30. Am I correct? Since the outside is 60, yeah, it's going to be 30 over there in that area, and the distance from here to here is going to be 6. Enter. It's going to be 6. So my distance here is going to be 30. Yeah, obviously 30, because looking at our distance here, the distance from here to here is what? Is 30. So I think I'm correct. So then I can actually click on project geometry, click on this, and what? Okay, do you see that? Then I'm going to what? Finish sketch. Finishing my sketch, I'm going to pick revolve. With revolve, I select what? Axis. I select axis. With my axis I pick this, then I pick what? Cut. So I'm having that fine shape on the inside, as you can see for yourself. Do you see that? So after that has been done, I'm going to what? Thread it. It is fully threaded on the inside there. So true or okay, then what? Okay, so I've threaded that. So I'm going to save it as, let me save it as my ruler shaft as my ruler shaft. So that is done like that. And I remember seeing the edge of this area here is chamfered, so I'm going to pick my chamfer. Let me just use 2 for that side. Okay, then okay, the area is chamfered like that. So I'm done with this. So I'm going to create a new working environment. So now to get my fourth component, okay, which is what? The cast itself. So now if I take a very good look at this, I'm going to actually develop this object from this view where my cursor is hovering about. I'm going to actually develop it from this view here. Okay, so take note of that. So writing on my start sketch, picking any of the plane there, I pick, let me do a rectangle first of all, like this. So that rectangle of what dimension? Okay, 16 by total dimension from, okay, that will be 16 by 64. 16 by 64. Okay, 64 16. Okay, 16 by 64, like that. So I'm going to actually move it to this junction. So we are having a dovetail, okay, so which is something like this, So I'm going to create a line on the middle here to actually balance my work. Okay, so I'm going to pick this constraint, that's a symmetric constraint. Okay, I'm going to pick here and what, this junction here. Likewise, I'm going to pick here and okay, I think it's already set there. Okay, now is dimension. Okay, with my dimension, okay, that place is 16, then 60 degrees. Here to here is 16, then on the inside there is 60 degrees. So what about the height? The height is 6. Here to here is 6. All right, so I'm having circle of diameter 25, diameter 12, don't forget. So let me just create this here, diameter 25, diameter 12, and I'm picking a line, that line from here to here like this, and another line from here all the way here. So take note of what I'm doing, please. All right, so dimensioning that, right, yeah, from the middle right here to the center here is 13. Enter. So that one is figured out. And obviously from the I'm coming. $38 from this middle to this junction here is 38. Enter. All right, so I'm going to use my tangential constraint, this to this circle, and this circle to this also, like that. So now we are having these two circles here. All right, it is actually not 2 circles, it is a countable O. Okay, so the first one is diameter 10, the second one is diameter 5 at a depth of 2. Countable O, diameter 5 and diameter 10. So I'm going to create those O's right there, then use dimension to position them. Diameter 5 and diameter 10, diameter 5 and diameter 10. Okay, with my dimension, so distance from the center of this O to the center of this bigger circle is what? Is 8. While the height from the top is what? Is 19. 8 and 19. So here to here is 8. Is 8, and here to the top here is what? Is 19. Enter. So I think that is sorted. So what else am I looking for? I think I am good to go. Yes or no? I think that's a yes. That's a big and fat yes. All right, that's a big and fat yes. So I'm going to finish my sketch right now. Finishing my sketch, I'm going to click on my extrude. Okay, with my extrude now, so the total distance at the bottom is what? 102. Then I'm going to make it symmetric. Okay, I'm going to make it symmetric. 102. So I'm going to make it symmetric like that. All right, so with my plus, so the next is this region here. Okay, yeah, so okay, I think that actually goes with the bottom there, so my bad, I should have picked it together. So 102 also together with this whole, am I correct with this all of it thing? Okay, I think I'm good to go. Yeah, like that. Let me just pick that one. So like that at 102. I should have done it together actually, but my bad, that's my mistake. So I'm picking this and this again, but what dimension am I going to give this now? So I'm having 108 minus 34. 108 minus 34, that's the dimension I'm giving that area. 108 minus 34, because 17 plus 17 is 34. Am I correct? No. Okay, I'm having 17. I'm coming. Okay, I think it's straightforward. So if here to here is 72 and the distance from here to here is 3, so which means this is also what? 3. So 72 plus 6, that's 78. So that would be 78 symmetric, then what? Cut like that. Then with my plus again, then I'm picking this obviously at 108. I'm making it symmetric like that. Okay, then what? My plus again, then I'm picking it again. Now this time around is going to be, it is going to be okay, 17 to the left, 17 to the right, that's 34. 108 minus 34. 108 minus 34. That's what I'm going to pick, making it symmetric. Then I'm cutting. Am I correct? Before I made mistake. 108, yes, minus 17 plus 17, 34. Yeah, 34 should be giving me okay, I think that should be 72 plus 6, 78. Let me do 78. 78. Yeah, I'm correct. Check. So we have this like this. Perfect. I'm having that like that. Perfect. Okay. So should I do this on the outside here? Yeah, let me do it on the outside here. Okay. On the outside here, I'm going to create a sketch. So on this sketch, I'm creating a hole. This hole is going to be diameter 10. Enter. So if you look at our question, that hole of diameter 10, the depth is what? 2. The depth is 2. Sorry, the depth is 6, so not 2. This is the depth is what? Is 6. The depth is 6. So I'm going to extrude that at what? 6 towards the inside. Then I'm what? Okay. So I'm going to replicate this feature to the other side here. So what do? My plane is going to be XY plane. So I'm going to pick mirror. I'm going to pick mirror, picking this feature. That feature, picking my XY plane. Then what? Okay. So if I turn to the other side, it is already there. That's it, you see, just like magic. I know you'll be asking me, how do I know that it is XY plane? Okay, now if you look at this, when this object is sitting like this, this object is what? Is facing this direction. It is facing this direction like this. Now look at my plane indicator here. So which plane is actually facing this direction? X plane, and what? Y plane is the one facing this direction. Do you see that? So like that is how I actually deduce that it is what? XY plane, because that is the plane facing this direction. If I were to look at it from this direction, that would be going to be what? YZ plane. You see, Y and what? Z is the one facing this direction. We can see for ourselves. Okay, let me pick it so that you can see. Let me pick YZ. If I pick YZ plane on my origin, see, YZ, do you see? So that is it. Cheap like what? Like plantain chips. Easy as ABC. Fresh like Maekll Tech. Alright, so that is that about that. Now let us do all the orishi on the inside here. Clicking on this area, clicking on start sketch. Okay, I'm having the first bigger circle, diameter 25 on the outside. Then on the inside it's going to be are you giving dimension for the one on the inside? Where are we giving, Mike? I know 25 on the outside. That one is straightforward. Okay, if you are not giving me, I'm going to use 12 for the inside since it is not there. So 25 on the outside, 12 on the inside. 25 and 12. Okay, now if we take note, we have these holes here and they are countersunk hole. Countersunk. So you should know the difference between countersunk and counterbore. Okay, so counterbore hole, I'm going to draw them in orthographic projection. So if it's to be a counterbore hole is the one I actually did over there. So its orthographic projection is going to be like this for a counterbore hole. That is it. That's a counterbore. But if you have to be a countersunk hole, it's going to look like this. Okay, yeah, that's how a countersunk hole actually looks like, and you can see that that's the shape you're actually seeing here and seeing here. That's a countersunk hole. Okay, so that is that about that. And you can see that counterbore. See this shape. You can see the shape for that counterbore hole here, and you can see the shape also. So that's the difference between a counterbore hole and a countersunk hole. All right, so that is that about that. So let me create my countersunk hole. Countersunk hole that is given here, that we're given here. Okay, so let me look for dimension. Okay, diameter 5 and diameter 11. Diameter 5 and diameter 11. So I'm going to come here with my circle, be somewhere here. I produce diameter 5. Okay, let me just produce diameter 5. I don't even need the 11. So let me create this line here as a reference. Let me make it hidden actually, like this. Then I'm going to create another line on this axis for reference also, so hidden also. Now with my dimension from the center to the left and right, that's 25, which means from here to here, the dimension is what? Is 25. Enter. Okay, and from the center to the bottom there is what? Is 8. So from the center to here is what? Is 8. Enter. So I'm going to use mirror. Yeah, let me just do it here straight away. I'm going to mirror this mirror line. It's going to be this. Sorry, mirror line is going to be this. Apply, and what's done. So I'm going to use my mirror again. I'm going to pick this. Mirror line is going to be this. Apply, and what's done. So I'm going to finish my sketch. Finishing my sketch, let us deal with this one on the center first of all. Okay, now I'm going to extrude that bigger one outside at 2.6 to the outside, then all through 2.6, then this one through all. Okay, yeah, okay. So share the sketch. Now I'm going to come here. I'm going to come to hole. So on my hole here, yeah, I need a countersunk hole. I think, yeah, this you can see countersink hole. So with my countersink, I pick this. So picking that, now let me fix the dimension. So the dimension of our countersink, if I look at the information, diameter 6, diameter 11 at 60 degree. Diameter 6, diameter 11 at 60 degree. 6, 11, 60 degree. So I'm going to do that now. So diameter 6, sorry, this one will be diameter 11, not 6. 11, 6, my angle is 60 degree, and the total height of that thing is going to be okay, that's total height of 10, since it's actually stopped in that side. Yeah, that's going to be total height of 10. Total height of 10. All right, so I'm going to now replicate it here. You see, I'm going to replicate it here, and what? And I'm going to replicate it here also. This thing is misbehaving. You pick now. Why is it picking dimension? Oh, this one doesn't want a pico. So I've done for the 3 axis. I don't know what's wrong with it. So I can as well just mirror it to the other side here. Okay, so that's going to be YZ plane. So mirror, okay, that's it there. You can see, easy peasy, like pizza. Clicking on this, I can hide the sketch. So I'm going to fillet this. That's going to be 2.6 fillet. Yeah, so like that. Then okay, and I think we are still going to do some fillets also. There are some fillets. Are we giving the dimension for the fillet here? No, we are not giving, but let me just assume. So let me pick fillets. I'm picking 3 for everything here, and here also. Okay, here and this place also 3 here, and okay. So I think we are okay. So I'm going to call this my casing, CASING. Enter. So having everything like this, let me just pick material, just give it some finesse. Here you get. So let me make this Okay, let me make this iron cast. Iron cast is not that bad. Okay, let me make this steel. Carbon steel is not that bad for this. Okay, yeah, this also carbon steel is not that bad. Okay, and my washer. Okay, let me just use something like this for my washer. Okay, now I'm going to assemble it together. Standard mm.iam. Okay, my 4 components straight away, I'm going to pick them now. Sharp. So clicking on place, bolt, casing, roller shaft, washer, and what, open, dumping them. Bam. So that washer is going to be 2. Ctrl C and Ctrl V. I have my washer in 2 places like that. So, and like this, and like this. All right, so now I'm going to use insert. With insert, my first washer is going to be here, apply. So my second washer is going to be here, apply. Then this is going to actually sit here like this, apply. Then this is going to sit right here like this. Do you see that? And what? Okay, and that is our what, our object. Can you see that? So view, I can make it realistic. So making it realistic, can you feel it? You can see it, right? So that is it. Straightforward, cheap like what, plantain chips, easy as ABC, easy as ABC, cheap like plantain chips. That is it. Straightforward design, everything is straightforward, you can feel it. So that is it. Chakam, and what, and chakam. Okay, so let me just save this, don't let me keep romanticizing it. Okay, so after saving it, my orthographic, I don't need to do orthographic now, you guys can do orthographic by yourself. So that one is straightforward. Let me just do the presentation view so that you see how this thing roll. So presentation view, standard mm.ipn, create. So creating presentation, I'm going to click on this. Yeah, that's my assembly there. I'm going to click on open. So with this right here, I'm going to click on tweak components. So the first component I'm going to remove is this bolt. Take note. So in that order, this bolt like this, followed by this washer. Okay, I drag it also outside. Okay, followed by this, and this one is going to be what, like this. Then followed by this, which is also going to, first of all, it's going to first of all come here. Oh, then who cares? So then what, finish like that. So if I just play it, you see it's going to show how it's got disassembled. Sharp, and sharp. Okay, and with this it goes back all the way right there and right there. Okay, and this brings us to the end of this tutorial video. Once again, my name remains Oluwatumbi Blessing or Lalekon, the founder of Maekll Tech. Kindly ensure you subscribe to this YouTube channel and also refer it to your friends who might be in need of it. Thank you.